We're going to look at area and volume questions, including a couple of polar graphs. And we're going to use free response questions to do this because they are particularly well suited to going over area and volume problems, especially when you have to show your work and you have to show your formulas. So let's work our way up through the different concepts here. Area is basically calculated by using a Riemann sum, and specifically a definite integral is a limit of a Riemann sum. That means what would you expect the sum of the areas of all your approximating rectangles to be if the number of rectangles approached infinity? You'd expect it to be the exact area of the region between two curves or bounded by two curves. And the way you set it up is this definite integral formula, where the integrand, the thing that comes after the integral symbol, is essentially the formula for the area of one approximating rectangle. Rectangle height times base. I know we normally say base times height, but it doesn't matter what order you do that in. And just so you're aware, the height is calculated by finding the distance between the two curves. If you're making your slices vertically, then it would be upper y value minus lower y value. Horizontally would be x value on the right minus x value on the left. The base is always just dx or dy, always. All right, so with respect to x, your area is going to be that same formula, but again, the height of your rectangle is upper y value minus lower y value, and with respect to y, the height of the rectangle is now laying horizontally in the image, and it's the right x value minus the left x value. It's also important to note that your limits of integration match the variable. So if it's with respect to x, a and b are starting and ending x values. So from the left to the right, a would be on the left, b would be on the right, generally when you're finding area, although that can be reversed for just integration problems. If you're talking about y, then a is your lower y value and b is your upper y value. Now this pattern keeps repeating over and over and over again as we go through the volume methods. When we take an area of a region, we take that slice that represents one rectangle and we spin it around a line of revolution. So the first method is the disk method. You'll notice the formula looks fairly similar here, but now it's the formula for the volume of one cylinder. That's pi r squared h. And again, the radius takes the place of the height of your area rectangles. So same formula set up to find those things. You just have to remember to square whatever that expression is. The height of your cylindrical disk is going to be dx or dy. Your limits of integration are, of course, going to be x values when it's with respect to x, and y values with respect to y. There should be a pi in front of this one over here. And this is used primarily when your line of revolution is a boundary of the region. If there's no gap between your region, no open space between the region between the two curves you're talking about and the line of revolution. If there is a gap between those things, we have to do two volumes of cylinders and subtract the gap cylinder from the outer solid cylinder. And that's the formula here. You need a big R and a little r. The thing that's important to remember here, that when you draw your radius line segments, again, back to area, those line segments were the same line segments you would draw to represent the height of one rectangle. But when you draw them here as a radius, you start always at the line of revolution, and big R will be from the line of revolution to the furthest boundary of your region from the line of revolution, and little r will be from the line of revolution to the closest boundary of your region. And then you do the upper y value minus lower y value to find the length, or if it's horizontal, x value on the right minus x value on the left. Those are the two main solid of revolution volume methods that we use here. There's a third type of solid that we look at, and that is the volume using known cross sections. So that area between your curves laying in the xy plane becomes what we call the base region, and you have to represent the area of one of your cross-sectional slices. So they'll tell you the cross-sections are squares or rectangles, semicircles. It has to be something with a line segment as one of its edges or one of its dimensions so it can lay flat and then come out from the XY plane perpendicular to that to create a three-dimensional solid. So your job here is to come up with an area formula for your cross-section if they don't give you one. And the way that you do that is, like it says here, number 1, write an expression to represent the length of one slice. And that's going to be, again, that same pattern. Upper y value minus lower y value if your slice is vertical. X value on the right minus X value on the left if your slice is horizontal. That slice is one dimension of your cross-sectional shape. Then once you find the length of that, you write an area formula. That's step 2. And then you integrate whatever that area formula is times the thickness of one slice. And again, the thickness of one slice is always dx or dy. That's the idea. Now, of course, we have polar area as well. So polar area here is from the area of a sector. So you're still integrating. Right? You're basically slicing your region up into an infinite number of sectors of a circle. And when you do that, you use this formula here. 1/2 times the definite integral from your starting angle of rotation to where you end the rotation of your radius squared d theta. And if there's more than one curve, very much like the washer method, you do the outer radius squared minus the inner radius squared, and that will give you the region that you're looking for when you're finding the area. So let's look at one free response question, and then in the next video we'll look at some of the other ones. So fairly straightforward here. This is calculator active, so if you want to try this on your own along with this, you'd have your calculator ready, and you'd be putting f of x into y1, and maybe y equals 4 into y2. All right, so find the volume of the solid generated when r is rotated about the horizontal line, y equals -2. If you have a diagram, sketch all over it. I'm going to draw in a little line segment for y equals -2 over here. And then, again, there's a gap between region R and the line of revolution, so I have to use the washer method. So I'm going to need a big radius and a little radius. So again, draw these things perpendicular to the line of revolution. And since I'm using the washer method, there's my formula. Like I said, I need a big R and a little r, a big radius and a little radius. So I start at the line of revolution, and I draw from there to the further boundary of my region. That gives me my big radius. I have to represent that length, so upper y value minus lower y value. That's 4 minus -2, so big radius is equal to 6. Now my little radius, from the line of revolution perpendicular to it, to the nearest boundary of your region R in this case, and I need a length for that, so upper y value minus lower y value, and I wind up with f of x plus 2. And I just put that into my washer method formula. Just don't forget the pi in front of the integral. And since this is calculator active, the rest of this can be done on the calculator using Math 9, or if you're using the Desmos embedded calculator, just choose from functions, the calculus menu, and the integral symbol, and you set it up that way. All right, so we wind up, again, with having to evaluate this, and of course you need your limits of integration. Now, they didn't give us that, so back to the calculator. Use the calculator to figure out where y equals 4 intersects with f of x. Right? You don't need to show work for that. You can just make a statement that they intersect there on a calculator active question, but you got to state where they intersect, then put those into your limits of integration, and now use the calculator. Let me get rid of this down here, and your volume by the washer method should be 98.868. We'll continue with this question in the next video.